Rahul will be talking about the storage, both the bulk storage as well as the small storage.
So good afternoon, everyone. Thank you for staying back before the lunch session. So to get started, I'll directly jump into basically role of energy storage. Again, in India, we are not new to energy storage. I think most of us have some form of UPS, lead-acid batteries at home, as well as I think as a general at global level, as a energy storage, pumped hydro technology is very well known. But energy storage, with the way the technologies are evolving, can play a very critical role across the entire value chain in the electricity grid. As I said, that already there is more than 80 gigawatt of energy storage installed around the world in form of pumped hydro facilities, which is playing critical role in various countries such as US, Japan, or Europe. There are also other bulk storage technologies such as compressed air energy storage, which are being developed for 100 to 500 megawatt kind of a range. There are already existing which can be deployed at hundreds of megawatt scale for mainly providing renewable integration support or for optimizing transmission capacity. But apart from that, what's amazing right now is that there are possibly over 20 plus different type of energy storage technologies which are being developed, which can be deployed right from few hundreds of kilowatt to tens of megawatt scale. And these technologies can be deployed very effectively at transmission and distribution level. There are technologies such as sodium sulfur batteries which have been deployed in Middle East and Japan quite widely for distribution system upgrade at a scale of 1 megawatt to 10 megawatt. There are large scale lithium ion batteries which have been deployed for ancillary services around the world, mainly in US as well as Latin America. But at the same time, there is this concept related to microgrids or community storage systems which is coming up, where again you can start looking at anything from 3 kilowatt to maybe hundreds of kilowatt systems which can be utilized for effectively addressing various distribution challenges. Here is a chart which shows various storage technologies, and the way you read this chart is on the x-axis you have the power rating, so in the scale in terms of megawatt, and in the y-axis you have the discharge duration. And please remember that both these scales are on logarithmic scale, so if you change this to a linear scale, then basically pumped hydro storage, which is right now on top right corner, it ends up taking almost 90% of the space, which is maybe the reality in terms of the current installed capacity. But in terms of the future of the technologies, there is tremendous innovation happening in the electrochemical or mechanical storage space with technologies such as lithium ion, various flow batteries, isothermal compressed air energy storage technology, gravity-based storage technologies, and it's going to be really providing a range of technology solutions at various performance as well as price points. So when you are selecting energy storage technologies, there are various parameters which can determine if the technology can be deployed cost effectively for particular application or not. Lots of time what happens is that people tend to focus only on the capital cost. So okay, what is the capital cost? How does it compare with a lead acid battery? But now if you just think of your own cell phone, now for the traditional cell phones which we originally had, can you use the same battery which you had for a simple cell phone in a smartphone? Probably not, because now the entire usage of the phone, the power rating, the type of applications which are running on our phone is completely different. So you have to graduate from to a different, more effective type of storage technologies. And same thing is going to happen even at the grid scale, where maybe for substation backup batteries, lead acid is a perfect solution, where you're looking at mainly using it only few times in a year, and maybe 100, 300 cycles is a sufficient lifetime, looking for 5 or 10 year cycle. But when you are starting to look at applications such as renewable integration, ancillary services, where you may have thousands of cycles every year, these technologies are not optimal. And that's where various additional new technologies with high round trip efficiency, with high cycle life, are finding lots of traction amongst various users. Here is a map which shows some of the smart grid demonstration projects deployed in US, where various type of technologies including flow batteries, compressed air energy storage, flywheels, lithium ion, as well as advanced lead acid batteries have been explored for all different type of applications. coming back to India, at India Energy Storage Alliance, we have been looking at energy storage applications in India for over last year or so. And we think that there are obvious value propositions in India where actually the need is much greater than in developed countries like in US, where, for example, in US currently has a total installed capacity of over 1,000 gigawatt of supply with a typically somewhere between 15 to 25% of reserve margins, whereas in India we are operating the system with typically negative 10 or negative 15% reserve margin with mainly peak shortages. There are a number of industrial areas, number of townships which have to rely on diesel generator, where the cost of energy production becomes 15 rupees, 20 rupees if you start accounting for losses and pilferages which take place. So if you start looking at the opportunity in terms of the cost of electricity during the off-peak time and the price for peak energy which the consumers are paying, then there are tremendous opportunities which are available. Also, we have seen challenges in terms of the blackouts recently in India, which is creating interest amongst the regulators for creating ancillary service markets. And again, it has been proven in last 5-6 years that energy storage technologies are one of the most cost-effective and ideally suited for providing these type of services. And I'll share some case studies with you in this presentation. So just at a high level, we have looked at these various applications in India, and our assessment suggests that technically there is a potential for almost 15 to 20 gigawatt of energy storage in India. And it may seem like this is a very high number, but I'll tell you that if you take out some of the specific applications, for example, wind integration, there is a recent study done by Power Grid Corporation where actually they have put the requirement for wind integration just from Power Grid perspective at somewhere between 5 to 7 gigawatt. And as part of this study, we are estimating that at around 1.6, 1.7 gigawatt level. So again, we have tried to be relatively conservative in terms of our estimate, but obviously we are going to continue working on this in terms of building case studies for specific industries, looking at the cost effectiveness and trying to map different type of technologies with different applications in coming months. So if any one of you are already working on energy storage projects, I'd encourage you to get involved with ISA activities and be part of this exercise. So here is some data on the Indian grid frequency. And again, if you are familiar with the grid balancing around the world, typically in developed countries, the grid frequency is maintained within sort of a 0.02 hertz band. Whereas in India, very often the frequency goes down almost as low as 48.8 hertz. And typically this is just one sample day where you can see that number of times the frequency was going below 49.2 hertz. And for addressing this, right now, typically utilities are relying more on sort of load shedding or under frequency relays. But if you see what happened during the blackout on 30th July, after some of the overdrawing states were disconnected, obviously there was a big jump in terms of the frequency. And again, if you are talking about these type of frequency jumps, you cannot address those by doing more under frequency load shedding. So that's where I think adding flexible capacity into the grid, having ancillary services into the grid with flexible generation can help tremendously for addressing grid reliability challenges. So the one concept is ancillary services. Basically, you can think of these as more of a balancing services for managing second-to-second variations. And particularly frequency regulation is a service which is considered very critical. And when you are providing this service with just traditional fossil fuel-based generation, then you are obviously limited by the general laws of physics, the inertia. So on the left-hand side, on the top, you can see the chart where the dotted green line shows a typical area control error signal, which is basically showing the mismatch between supply and demand, and a response from a traditional fossil fuel-based generation, where you can see that the fossil fuel-based generation cannot instantaneously match the regulation signal requirement. And as a result, typically what happens is that the system operators, if they really want to maintain frequency, have to procure a lot more capacity than what is required in terms of absolute deviation. On the other hand, if you replace this traditional generator with a fast energy storage resource, then various technologies such as flywheels or advanced batteries can be used for instantaneously match the regulation requirement. And there have been studies which have been done to show that this can result in a reduction in the regulation requirement by up to 25%. And again, when in case of India, when we are just creating a new market, if we create the right price signals, then we can start from the start and have right type of technologies being used for these applications. On the second side, in the Indian context, we know that right now the total installed capacity in India is only around 200 gigawatt for the entire population of 1.2 billion. Whereas if you start thinking about the future needs of generation, we are talking about various studies depending on, you assume 6 to 10% of economic growth, suggest India needs to add somewhere between 400 to 1000 gigawatt of new generation within next 15 to 20 years. Now, we are not going to be able to do this just with coal or centralized thermal power plants based on even the current shortages which you are facing with current UMPP projects. So renewables are definitely going to play a very critical role, but at the same time, when you are talking about renewable technologies, you have to differentiate between the installed capacity and the available capacity, because most of the renewable resources are subjected to significant variation based on time of the day or based on availability of the sun and wind. So what's a critical difference between a renewable dominated system versus a traditional system? In a traditional system where you are not doing load shedding, typically you will expect sort of a load shape which is shown in the curve in the red in the background, where you can see that, okay, during daytime the load peaks, night there are valleys, and then again the load will go up. But you'll notice that the base load during this traditional system in this example was somewhere around 10 gigawatt. Now, when you start adding wind and start treating it just as a negative load, you are basically trying to do it is you are trying to use your existing generation resources and try to meet the effective load curve, which is shown in the blue. Now, there are significant differences between the load shape in the red versus load shape in the blue. First of all, as compared to the base load of 10 gigawatt, the base load has now come down to 5 gigawatt. So if you're relying on resources such as nuclear power or coal base load generators, you are going to have certain challenges in terms of going down on your base load capacity. The other issue is in terms of the ramping capacity, both in terms of the ramping speed as well as the total amount of flexible generation which is available in the system. And earlier, people used to think that, oh, but with solar, since sun is shining during the day when the load is maximum, it is actually a very good match for reducing load. But there are again significant issues still with solar. One is with the cloud coverage, with dust issues. When you start looking at second to second variations, there are significant variability available with solar as well. And the second part is typically in the Indian conditions where the most of the times the utility peak loads happen after 5 p.m., maybe around 7 p.m. That's a time when the solar output goes back to zero. So again, there is a significant need for adjusting the output both for wind and solar. So here is an example of where in US, a company named AES, which is one of the largest independent power producers in the world, has used a 30 megawatt lithium-ion battery for wind smoothing for a 110 megawatt wind farm. And actually Customized Energy Solutions is operating this facility as one of the 3000 megawatt resources we operate in US, where what we are doing it is that wherever there is a requirement for wind smoothing, there is a significant deviation between the day ahead versus real-time forecast, then we can use the battery for providing wind smoothing services for the wind farm. But when it is not required for doing these wind smoothing services, the same battery facility provides ancillary services to the grid and gets paid for it. And again, with the recent market rule changes where there is pay for performance regulations introduced in US, this facility on its own is cost effective for providing frequency regulation. And when you add on top of some of the additional incentives which the facility can receive as a tax incentive or other thing for providing renewable integration, it overall becomes a very strong business case. AES itself has already announced plans for deploying more than 1000 megawatt of energy storage facilities around the world. Here is another example from Australia. This is an example from a company named eCold, which manufactures ultra batteries, which is a hybrid between lead acid and ultra capacitor batteries. And what they have shown here in this example is that a typical wind farm output, which is shown in the blue, has a significant fluctuations, but the Australian grid has certain existing resources which can meet some of this variation. So they have come up with an algorithm to try to say that, okay, our goal is not to completely convert a wind output into a completely flat output, but we want to basically just adjust the variability to the extent so that the existing resources can take care of it. And that's what is shown, where the output of the battery is shown in the white curve at the bottom, which ends up basically reducing the variability of the wind farm from the blue line to the orange line, which is manageable by the existing grid resources. Similarly, in terms of the solar, you can think of it where during daytime you can use the battery for adjusting the variability of the solar output, and during rest of the 15 or 16 hours during the day, you can provide grid services. On the other hand, again, another example from eColt, where what they have done it is, this was a completely grid disconnected system where they keep on storing some amount of energy throughout the day in the battery. And the earlier evening peak which I talked about, basically they are using this stored energy from the solar to offset the evening peak by changing basically the output shape from the solar panels. Now, Terry has already talked about microgrids, so let me jump to some specific applications of energy storage within microgrid. Typically, when you are talking about completely grid disconnected microgrids, you will have some kind of a diesel or some local generation resource which is providing basic power. But as you start adding wind and solar, basically your existing generation becomes your just backup generation, and you are continuously ramping them between maybe 10% to 90%, which ends up increasing your fuel consumption, ends up increasing your wear and tear on the equipment, your O&M cost. So you can use energy storage as a buffer, where the goal is maybe not to eliminate the diesel generation altogether. And of course, you can design systems where you can oversize the wind, solar, and you can oversize the storage and completely eliminate the storage. But based on various studies, sizing studies, what we have done, I think the most cost-effective solution right now is maybe have a diesel generator as part of the system, but try to minimize the usage of the system, so that typically either the renewable resources plus storage can take care of the entire load, and only time when you do not have renewable resources completely or when the storage is depleted, you rely on the diesel generator. And these type of systems can be deployed very cost effectively as compared to the cost of the diesel generation itself. And again, microgrids, you don't have to think just in terms of rural areas. If you start seeing the current trend where more than probably 300 townships are being developed right now all over India, just outside Pune or close to Pune, I think there are probably around 8 to 10 such townships being developed with probably 30 to 50 skyscraper buildings with a SEZ, with school, hospital, shopping mall. Then you can start thinking of this each area as a microgrid in itself. And under the Indian Electricity Act, there is a provision for some of these SEZs to become their own license area, and that could be another concept where people who are investing into these microgrids can recover their cost investment through providing better quality of power and reliability to the consumers. Here is an example of a microgrid testing center developed by Dynapower, which is one of the leaders of providing power electronics for energy storage integration. Also, commercial and industrial customers can use it for various applications such as peak shaving, renewable integration. And again, if you think of the challenges being faced in customers right now in say Coimbatore or in Tamil Nadu, where they have been asked to go for a 3-day holiday every week, or maybe have somewhere between 12 to 16 hours of power cut every day. There is more and more interest in trying to use maybe wind solar hybrid for meeting the power needs for these industries. And again, that's where adding right type of storage technology can help in optimizing overall costs. So to end, I'd just like to mention that as part of the India Energy Storage Alliance, we are working with various stakeholders both within India as well as through international community. We have developed strategic partnerships with all the global energy storage and microgrid alliances. And already earlier this year in October, we had 6 leading companies working in this area, including Google, Alter Nano, Enerdel, Dynapower, eColt, Dia, and ZBB, who participated all over India. And again, we are expecting actually additional around 10 to 15 companies to visit India in March. So if you are interested in this area, and if you are interested in getting into any projects, then please stay in touch, and we can send you more details of this. So to summarize, I think the way we expect the Indian economy to continue growing, I think the wind, solar is going to play a very critical role for in the supply mix for the India. Of course, it's not going to be only wind and solar. There is a role for fossil fuel, nuclear generation as well. But we are going to see a significant increase in the penetration of these renewable resources, as well as deployment of microgrids for both commercial as well as rural areas. And there are proven technologies. Again, as Terry mentioned, I don't think these technologies are just for the future. There is enough work being done in last decade where I think some of these technologies are already viable right now. But at the same time, tremendous innovation is happening, where particularly in next 3 to 4 years, you will start hearing about number of new technologies such as zinc air, lithium air batteries, sodium ion batteries, which is going to make the field a lot more exciting. So even if you have found out for a particular application right now, a particular technology is not working, keep an open mind, and I'm pretty sure that in next 2 to 3 years, we are going to see much more deployment of these technologies all over the world and also in India. Thank you.
Thank you, Rahul. You addressed the major the item, that is the storage. In fact, without storage, I think the microgrid cannot work. And I have seen that even my own personal business, when I'm looking at the applications in the industries like in Coimbatore and even some of the remote areas, what is really hurting us is the storage media, which is required today. Yes, a lot of technologies are happening, a lot of changes are happening, a lot of developments are happening. But what is important is the affordability of the technologies. I think that is, as you said rightly, yes, the things are happening, and this will definitely lead to an affordable technology or a product in the future.